Yeah, so one of the things we've been looking at working with Boeing is multi-vehicle collision avoidance work. And so we're actually flying it here in the high bay using the UAVs behind me, thinking specifically about how these vehicles plan around the other vehicles that are also in the environment. So one of the challenges here is scaling up the algorithms. So we're looking for decentralized calculations, so the vehicles are each themselves computing answers. They're sharing those answers amongst themselves using a wireless communication network. And then using that information in this exchange to then plan new routes. So I sort of liken this to something you might see in the in the airspace around us, where the airplanes are sort of able, the pilots have a mental plan of the path they're going to be following, and then those paths are being deconflicted, somewhat automatically, either through the systems on board or through the radar system, the air traffic control. But when we're flying UAVs around, that doesn't exist. And so what we have then is the equivalent of that now operational in our systems, where the vehicles are exchanging this information, deconflicting paths from each other, and also obstacles themselves. So there may be another obstacle that's flying around, which these vehicles can track using cameras, and then they're able to deconflict from those as well. So a combination of sort of exchanging that information, planning around it. So the algorithmic work is figuring out how to optimize those paths fast enough, and then also tracking the other objects. So we actually, as part of the path planning, are thinking about how to look and actually track the vehicles using the onboard cameras. So you have to make decisions about where to look and when to look is one of the key elements of this work. And one of the key pieces that we keep finding with a lot of this multi-vehicle work has to do with the communication delays that are often associated with exchanging information. And so accounting for that delay in the decision process that you want to be able to certify is still going to be correct. So if I make a decision to do something, I want to be confident I'm not going to make an incorrect decision based on old information. So we have to embed into the process an ability to handle that type of delay and understand that delays will happen, and yet we can still certify that the decisions we made by the UAVs are correct. So where it stands is we do a lot of flight testing here locally in our high bay. Our high bay is nice because we have sort of halves, and then we can use the entire space. And then eventually over the course of the summer, we'll be transitioning this to the Boeing lab and testing it there as well. Ideally, we'd be able to fly this outside. There's a hope that we've actually had a flight net put up on the roof of this building and be able to fly in the GPS environment outdoors, and then eventually fly with the bigger UAVs external as well. So.